Hey TechKnowStuds! So why do we use different numbering systems when it comes to computers? Well, let's go over the common numbering systems that we use on computers and why we use them. Now, one of the reasons is it gets back to those powers of 2. We want to represent different characters, we want to represent graphics, we want to represent different things on our computers. And so to represent that, we need to have a certain amount of representation. So for instance, if we needed to represent 4 different states, we'd use 2 to the power of 2. Let's say we wanted to represent 16 different states. Well, that would be 2 to the 4th power. So we would use 4 bits to represent 16 different combinations. If we wanted to represent 64, that would be 2 to the 6th, or we'd have 6 bits. If we wanted to represent 256, then we would have 8 bits for that. One of these numbers that seem to fit really well in a lot of different scenarios is this 256 possibilities, or 8 bits that we have here. And so we call this, we've labeled it as being a byte of information. And we use it as a form of measurement for a lot of different things. So that's a byte. But that's not the only time. If we were to use a full byte for everything, it might not always make sense. So sometimes we use half that. We use 4 bits, which is 16 possibilities, and we call that a nibble. So a bit is either a 1 or a 0. A nibble is 4 of those. A byte is 8 of those, or it could be considered as 2 nibbles. And we also actually call this an octet at times. One question that comes up is why would we want to use decimal versus why would we want to use binary? And why would we want to use hexadecimal, or why would we want to use octal? Let's first answer the question, why decimal? And the answer to that is pretty straightforward. It's what we're used to using. So in decimal format, this is much easier to read than a binary number. I'd have to, for binary, have to say 11000000, and so on and so forth, and it would get really monotonous, really quite crazy. So it's much easier to say 192.168.40.45. Then also, this is an IP address, so it's a little easier to say than hexadecimal or octal format. So if decimal is easier for us, why would we ever want to use binary? And the thing is, there are times when binary is just necessary. For instance, when we're subnetting a range, we have to really get down into the bits and what the bits look like. So it really is a requirement that we understand binary and can work with binary. So then the question is, well, why would we want to use hex? And the reason is because translating from decimal to binary is not always the easiest. And we can do it much easier with hex. So if we take a look at an example of this would be IP version 6. IP version 6 is a hex number. And that looks much better than if we were to do the binary equivalent or the decimal equivalent. It's a little crazy there. And from the conversion standpoint, since we do have to work a lot with binary numbers, it's just a lot easier to convert a binary number into a hexadecimal rather than decimal. And the reason for that is because here's 8 bits right here. So we got 8 bits of information. We just split it down into 2 nibbles here, and then we convert each nibble into a hex number. And so it can be actually fairly simplistic for this conversion. And why would we use octal? Well, one of the ways that we use octal is when it comes to file permissions in Unix or Linux systems. So here we have the user, group, and other, and for each one of those, we have read, write, and execute. These are levels of permissions for each one of these, the user, the group, and for everyone else. And so what we do is we set a flag. We turn on read, write, or execute for each one of these, the user, group, and other. And we represent that, for the computer at least, in the computer, it's represented as a binary number. So if we wanted to represent this in something other than binary, we could use hexadecimal, but then what we're doing is we're splitting this like this. We've got 4 here, a nibble here, we've got a nibble here, and then we've got this last little bit. And it just doesn't fit very nicely in here. So that's an example where we use the octal system. So what we have here is if we add up these bits, the 4-bit, the 2, and the 1 are all turned on, so that's 7. And here, right here, we've got 101, so that would be a 5. And here we got a 000, so that would be a 0. So then when this 750 number represents the permissions that we're giving to each one of these. So we're gonna see decimals, binaries, and hexadecimals come up quite a bit, and octal we'll see out there as well.